We have already learned about mass and on volume, and the last part is about concentration, which it has to do with solutions. And you have already somehow have an idea on concentration because we deal with it all the time. Even in our daily life, let's say for a drink, a more concentrated drink, it means that there's actually more solute added, but the volume is the same. So basically, that's the idea of concentration. And in science, in chemistry, it has to do with a solution whereby there's solute added to solvent to produce a solution. And we have a simple formula for us to calculate concentration, which is the amount of solute divided by the volume of solvent. Notice the unit here. The amount of solute can be in gram or in mole because these two can be interchanged. From gram we can convert to mole, and from mole we can convert to gram. And for volume we use dm cube. So the final unit is either gram per dm cube or mole per dm cube. And we can have a simple formula to help us. So using this formula, to find mole, we multiply concentration with volume. If you want to find concentration, mole divided by volume, we get concentration. So here we have an example. We have 58.5 gram of sodium chloride crystals, which is our table salt, dissolved in 1 liter of water or 1 dm cube of water. And you produce a concentration of 58.5 gram per dm cube, or we can say 58.5 gram is actually similar to 1 mole. So we can say it's also equivalent to 1 mole per dm cube. So here we have two types of concentration. One is by mass, the other one is by mole. And the units are according to gram and mole. Next we have an example. Here, 250 cm cube of 1 mole per dm cube sodium hydroxide solution. Now, 1 mole per dm cube, it doesn't mean that in this solution there's 1 mole of sodium hydroxide, because we need to calculate, because there's only 250 cm cube. So what we do is, if you want to find the number of mole of solute present, number of mole, concentration times volume. So we have to change this to dm cube by dividing by 1000, and then we times 1, we get 0.25 mole of solute. Just to let you have an idea of the solutions that we use in lab. For hydrochloric acid, if it's just 0.1 mole per dm cube, the pH is 1. And for sodium hydroxide, if it's just 0.1, it's pH 14. So this will give you an idea of how concentrated acid solutions are, and also alkaline solutions are. And now let's move to some calculations to convert between mole, concentration, and volume using this formula here. So you may pause the video for a while to calculate the concentration. And for part D, it's a little bit different because instead of mole given, we are given gram. At the end, we want molar concentration. Denote molar concentration. So you may pause the video for a while and do these questions. Alright, please check your answers. Let's discuss D. If you want to find the molar concentration, we use the molar mass. We divide the mass by molar mass, and we get 0.25 mole. We can say 10 gram is equivalent to 0.25 mole, and then only we divide by the volume, which is 0.5 dm cube. So the answer is this. I just want to clarify, in chemistry, for concentration, we always use molar concentration. Very rare that we use mass concentration, but you do need to know about that. For the last part is the reverse. You want to find the number of mole of solute, and we are given the volume and concentration. So all you need to do is just multiply the concentration with volume, but make sure the units are converted. For part D, you're given the mass concentration. Please change to mole concentration first before you multiply by volume. You may pause the video for a while to do the questions. Alright, please check your answers. I'd just like to discuss D. First, we convert the mass concentration to mole concentration by dividing by molar mass, which is 160. So after we have the molar concentration, we multiply by volume, then we'll get 0.01 mole. And that's all for today's lesson.